very good progress on the first / prototype Excalibre 15. As you can tell, I've got the tube sockets all mounted. I'll give you a close-up of the EF86 socket mounting for those versions that will have the EF86. These are all Belton sockets. V2 and V3 will have tube shields for those who want them. They're not necessary. This amp is going to be a hang down, and these Belton sockets pretty much lock onto 12AX7s. But some people like to have the tube shield, so you can put them on if you want. They've got these EL84 retainers and the EZ81 retainer. They are not my favorite things in the world. I have not yet found a better that's available at any reasonable price. There's a Belton, which looks better, but it's for when you have a PCB mounted socket and it's recessed to the board. So I'm gonna keep looking for my options on others in the future, but this is reliable and I can adjust the tension so that the tubes are snug. Once again, this hole is gonna get plugged soon. Let me show you some other little bits before I flip it over. I was in fact able to find some low profile thumb screw fuse holders. These aren't tight because these have to come back out before the amp gets its final assembly once the rear panel's on. And maybe in this video I'll show you what the rear panels are going to look like. That'll come later, but I like low profile stuff that doesn't stick out, but you don't have to have a screwdriver to do these. You can just do this with your fingers. And again, this is not in place. This is an IC cable, IC receptacle, and there's that vertical space that will be that'll be covered by the rear panel. So let me show you the next good thing. All right, the EF86 socket is isolated from the chassis with these rubber grommets. Looks like I need to loosen that one up just a slight bit. It's a little more compressed on that side, which just cushions it against vibration. And I might actually put another grommet in here as well, with a slightly longer screw, just to get a little more give. The trouble is if you have too much give, putting tubes in and out becomes really difficult. But this is the same thing Fender did on the 5E3 Deluxes in the late 50s, and it works well. I'm not doing a tube base on this or a tube shield because the full cover. It's a great way to introduce microphonics in an EF86, and B, EF86s are much more sensitive to capacitance than a 12AX7, and I have found that tube covers not only make them rattly, but they also make the sound darker, which we do not want. So yeah, I definitely need to loosen that side a little bit. That's no big whoop. Let me show you the inside of that. Okay, we've got nylock nuts holding each screw in place. And on old Fenders, when they did this with the washer, they would just have the nut here and then just a dab of paint. With these nylock nuts, it's not necessary. The whole thing, the screw and the nut can turn, but it will not loosen. So that's good. Now, these are neoprene grommets, and they'll probably last about 30 years before they need to be replaced. The ones that Fender used degraded, and I commonly have to replace those. And Matchless uses a lot of them, and those all degrade in Matchlesses. And I think they're using some kind of rubber, and they just don't last. These are neoprene. They should last a bit longer. You can see I've got the wires from 3 to 8, but also 2 to 7. EF86s use pins 2 and 7 for the internal shield. A lot of guys don't read the data sheet and they leave those disconnected. In theory, that should be connected to ground. In practice, tying it to the cathode is sufficient as well. As you can tell, there's a little dab of solder tying those wires there. So 3 and 8 are the cathode, 2 and 7 are tied to that. Will be much quieter without the added capacitance of a tube shield. Here on V2, I'm paralleling the two triodes, and it's hard to see in the video, but there's a good ½ inch of space between the cathode wire from 3 to 8 and the joined grids of 2 to 7. And all the resistors and capacitors in that circuit are adjusted to compensate for the parallel right into a shadow. It's funny how the eye sees things versus how the camera sees things. I'm trying to get the balance so you can see all the details, but that's going to give us a little bit of a blinding glare from my shop light. I'll just have to deal. Anyway, I've got the output transformer connections run. These jacks are not in place, so all these secondaries are just taped out of the way. They will go to the jacks later. I can't put the jacks on now because I've got to drill a hole in the chassis for one of them, and my rear plate is also my drill guide, so each one will get exactly centered where it needs to be. You can see I've got the standoffs. These are aluminum. They cost a lot less than stainless steel, and I have found for these purposes they are more than sufficient. You can see the ground lugs added. I'll do a separate video explaining my ground plan for this amp. It'll either be the first or second in the ground series, depending on which spot the Marshall gets. I've got my choke and output transformer primary center tap coming over here. This part of the choke will go to the HT fuse, which you can't see, it's down here. And the other part of the choke and the output transformer center tap will go here, which connect to the board to what is the screen node. AC15s of the plates and screens of the output transformer from the same B+ node, unlike most amps. It's a good way to get some additional filtering. It makes them unique compared to the AC30. It's one of the things that Vox hasn't done in a long time. Their AC15s that you buy are really just 15-watt versions of the AC30. And that's fine, but they sound different than what I'm actually doing here, which has a very different feel and compression and breakup character. The one ground I've already got connected here is going to be for the ground, AC safety ground on the IEC receptacle. I've got a heavy duty 18 gauge green with the yellow or the light green stripe per code. That is over here, separate from everything else. I've also got one ground here, which is going to the output jacks. And this will be where the entire screen and phase inverter and output cathode supply is grounded. And again, this is just a teaser. More on that in the final video. And again, on the front panel, I can't do any of the drilling that I need to mount the final components until I have the front panel mounted, because it also allows me to line everything up. But let me show you some fun progress I've made on the board. Okay, now first off, for those of you who see this and they see these radio electrolytic caps and thinks, that looks like a computer, bear with me, let me explain, trust me, I got this. We'll address that in just a moment. Second of all, you'll notice these wide gaps here, and that the second stage components aren't lined up well with V2, and the phase inverter is quite a bit far from V3. And the reason for that on this prototype, this first one, is that I designed this first board when it was going to be just pretty much 1 amp I was building, and Mojo Tone does not give the chassis dimensions and everything in detail, but from the looks of what I saw on the website and the dimensions I did have, I figured it was the same thing as a JTM45 chassis, just with 3 novels, where the JTM45 has 3 octals. And I was wrong. They have a much wider spacing on the preamp tubes on the JTM45, and they don't have this big hole right here for the filter cap, which means everything gets moved down this way. So if this were the JTM45 chassis, this would have been centered on V2, and this would have been centered on V3. I'll show you the computer graphic now showing this versus what subsequent Excalibre 15s will have, and that it will in fact perfectly line up with the tubes in question. Now for this first one, this prototype, it will not affect the sound at all. We're not adding much to the length. Everything we find is more consideration of how it looks and how easy it is for me to assemble. And I'm kind of cussing myself for not being a little more patient to wait till I had the chassis. But this will sound great. So I've got 3 mounting screws attached. It has 6. They're very nice. Everything transferred, no issues. I've got the ground wires in place, and I will address that in a later video, like I said. As to radial caps versus axial electrolytics. And some people associate these with cheap amps, and there's a reason for that association. A lot of companies do PCB very cheaply, and they will use the cheapest caps possible. Leland, Samoa, Illinois Capacitor. These are all crappy brands of electrolytic capacitors. Now, Illinois makes some good ones. Most companies don't actually spec them. But on the fenders that have so many problems with the Illinois, the problems are mostly with their axials, not their radials. Anyway, these are extraordinarily high quality Nichicons. They're a Japanese brand. These are rated for 105 degrees Celsius, 10,000 hours at 105 degrees Celsius. And these are 400 volt caps and 450 volt caps. The voltage in this amp is not going to approach 450. It's certainly not going to be 400, anywhere near 400 here, here, and here. It's not going to get anywhere close to 105 degrees Celsius. So 10,000 hours at 105 degrees, the actual temperatures in here with the actual voltages in here, this should last maybe 15, 20,000 hours. That is a lot of playing time. So eventually every electrolytic needs to be replaced, but these will go a long time before they need replacement. And when they do, it'll be very easy, particularly if you say, let's set the clock from the first time I play this. Let's say it's 13 years when these need to be replaced. In 13 years, I highly doubt that any axial electrolytics are still available. They're being discontinued by everyone. About the only company that's really making them in high quality at these large values is F&T, which is a German company. And who knows how long they're going to continue to do that. What about Sprague, you say? What about the atoms? Well, the atoms have gone way down in quality, and inside that big blue casing is a very small capacitor these days. They're not made the same way they used to be made. They cost an awful lot. They don't give you any performance benefit. I don't like using them at all, and I won't if I have any choice. In an amp where I have to use axials, I will use F&Ts in a heartbeat. And for smaller values, I like the Vichys, which still has some made. In the Marshall 76 I'm redoing, you'll see some axial Vichys, which are great. Who knows how long they'll make them. Nichicon, the same company that makes these great radials here, used to make a lot of axial electrolytics, and they stopped about, 3 years ago? Just abruptly stopped. And, I don't want to design an amp that cannot be serviced in the future easily. So in the future, if this is the cathode bypass cap for the output section, if it needs to be changed, odds are there will still be a 100 microfarad, 100 volt radial with good specs available. Here and here, the same. In future boards, I might shorten these cathodes a little bit to get a little less span there, but there's still very little flex on these small caps, and they have almost no mass, so I'm not concerned about that. As to everything else, this is the same stuff that you would find in a Marshall build or a high-quality Fender build. These are very nice half-watt carbon films. They sound fantastic. Here for the dropping resistors, I've got some 2-watt metal film Vichys. Same for the screen grid resistors here on the output tubes. I have these 150 ohm output bias resistor, the cathode resistor for the output tubes. It sets the cathode bias kind of elevated off the board and just barely sticking in, because I may want to adjust this once I have the whole thing powered up and I know what the actual bias of the amp is with the B plus that we actually have. And this is an educated guess as to a very safe starting spot, this 150 ohms. It may end up being a little bit smaller value, which gives a hotter bias, maybe a little bit larger value, cools the bias off. We'll find out. All right, these little yellow caps here. You're going to be saying, oh my God, those are tiny. How can those possibly sound good? Well, those are 10 nanofarad 400 volt caps, which are the same things that Vox actually used in the AC-15s. I could go get new old stock WEMA gold trophy foils, and it's the exact same value, a very similar material, the exact same voltage rating, but you'd add about $400 to the cost of the amp. And you would not hear a huge difference, or any difference. In my experience, if you pay $400 for capacitors, you're damn sure going to hear a difference. But also in my experience, if I have two amps where the only variable is the capacitor, and I do a blind A/B test for a player or for myself, if it's truly blind, you imagine differences more than you actually hear them. It's random, and people will argue with that. But are you arguing based on what you've read on the internet? Are you arguing based on what you'd like to think, what makes sense to you in your heart? Or because you've actually done the discouraging process of A/Bing and testing all your assumptions yourself? I've tested my assumptions. These sound great. They have thicker leads than other axials available. I mean, I could use Mallory 150Ms. They're great as well. I find that their leads are a little bit thin. I don't like using them as well as this. Could have used orange drops. I'm glad I did not. An orange drop is a radial capacitor. It's designed to go into a short span, preferably a PCB. You can do it with eyelets if the span's not great, or if the unsupported length of it is up against the board. With turrets, with things up in the air like this, it's just a lot of mass to have flopping around. And on a side note, orange drops, people just use it interchangeably. There are about 6 different series of orange drops and the voltages that we use for tube amps. In this amp, I would use one of the polyester ones, not the polyurethanes, polypropylenes. So it would not be a 716p or 715p in these. 600 PS or 225 series or the 418 series would be good, but they're physically large. They don't fit well in these small turrets with everything else. There's not a lot of support for the mass. And they cost twice as much for no benefit in this. They're fine in a Fender if you want. This will sound authentic to the amp. I've got one little cap here. Let's see if you can see it. This one right here. This is not a pretty yellow cap like the others, because the cap, like the others that fits there, is very physically large and costs like 4 times as much as this Panasonic. And this is just from the screen of the EF86 to ground, and you will hear no difference between a $1.75 Vichy and a 40-cent Panasonic there. These Panasonic ECQs are fantastic. So it's not directly in the signal path, so there's no argument about that. It's reliable. It will probably never need changing, and it fits nicely there. So I think that's everything I wanted to cover in this video. I'm really pleased with how this is coming out. It's really pretty. And I've got some stuff on this board which doesn't make sense at initial glance. These here are just ground, so I can connect shielded leads from the grounds to the wipers of the volume pots, and that will also provide the ground reference in the volume pot, part of my ground scheme. So I'll explain all that stuff later. It's pretty cool. I like it. It'll make this amp very quiet, as quiet as an EF86 amp can ever be, I suppose. But this thing just gets better and better and better. A few other little things to show. On these cathode resistors in the preamp stage, with the cathode bypass cap, the capacitor is likely to need replacing much more so eventually than that resistor. That resistor will probably probably not fail ever, but if it does, it's easy to get to. But that cap will need to be changed first, in all likelihood. So I have the cap mounted above the resistor, so you don't have to remove the resistor to remove and replace the capacitor. In this Marshall, at this similar cathode and cathode bypass cap setup, I'm able to, because I'm not using a radial capacitor, I'm able to have them both mounted to the eyelet. And so again, it's easy to change this cap, though in this case it's a film cap, very unlikely to ever need changing. But on this one, here's one I did where they're on the same eyelet. On this one with this giant 330 microfarad cap, which is a silly value, which I would not use in an amp that I build just because of the way it works. But I decided just to do the Marshall thing and avoid arguments in this one case. There was just no real elegant way to get the resistor beneath or to the side of the capacitor. And so I decided in this case just to have the resistor attached to the leads of the cap, which you see in a lot of Marshall builds, because it's an 820 ohm half-watt carbon film resistor. Everyone's got them. They're not expensive. You know, when it's time to change out that capacitor, you can change the resistor at the same time. No big whoop. All right, here's what the rear panel is going to look like. And I've got the mains fuse on the left, and the print beneath it is 2 amp at 120 volts, 1 amp at 240 volts. And I will black out whichever one is not being used. But unlike that Bogner from a couple weeks ago, it will never say 32 amp, no matter what happens to the Sharpie. Then the IEC receptacle, all fuses slow blow. Then the HT fuse, 500 milliamp, and that won't vary with the mains voltage. Then a little discrete logo. Then the serial number, which is actually just going to be an opening in the plate. And I will put a nice label on the chassis beneath, which will be revealed with the serial number. That's just the easiest way for me to do it, so that the serial number will be hard to tamper with, but inexpensive for me to do, and the plate over it will give it some good protection. I don't have to have custom print runs. And those really nice serial number stickers you find on things where the label does not peel up, those are expensive. All right, then we have the loudspeakers, 16 ohm, and then 2 8 ohm jacks. Says loudspeakers do not operate without correct load. Please take that seriously. Don't run the amp without speakers connected. I will be adding a little resistor in there as a backup safety kind of thing. It is not the same thing as a full dummy load. The amp is not designed to be used without a speaker connected. Do not do that. I'm trying to cover everyone's butt with a resistor, but it is a fail-safe, not a plan A. And here we have what is almost the final front plate. I've got everything that we discussed. I'm reversed the order of color and level in the output section due to wiring considerations. That'll just make it a lot easier for me to wire it neatly. And then I've done some massaging to the Excalibre 15 logo. Excalibre 15, British cathode bias. I've got to make Excalibre a little bit larger and play around with some baseline stuff so my wife doesn't kill me. You know, designer. I got to make her happy before I make you guys happy. But I think it's going to look really nice. There's also a little thing happening where the 1 and the 5 are joining that I'm going to refine and make that a nice little curve thing. I got to get in there and play with the actual objects and the anchors and stuff. Anyway, I'm so close to having the control panels finalized, at which point I can order them and then put one on the amp and do the drilling necessary and make it come to life.